First step in preparing our experiments is we clean everything with ethanol, just make sure it's all clean. The second step is we measure out 60 milliliters of our sample. So this is some Regolith, it's reduced Regolith. We measure its weight so that we can see if there's a change. And then that goes inside our reaction vessel, which is titanium. Then we take our aluminum sheath. This goes inside our decomposition chamber. It just makes it a lot easier to take things in and out, and also helps for powder collection. What we do for that is we just cover the entire inside surface with aluminum foil and then high temperature tape. And we record the weight of the tape and the foil just so that we can track and see if anything deposits on it. So we have our aluminum sheath with the aluminum foil placed in there. Next, we'll put on the cap for our aluminum sheath. That just goes over top. Then we put on the lid for the decomposition chamber. And then bolt it shut. Now that we have this set up, we have to set up the formation chamber. So we just assemble it. This just goes over top here. And then we just bolt the lid into place. Now that we have this set up, we're going to do a pressure check on our system. That's just to make sure that we're safe, we aren't going to develop any leaks during the experiment. So we just finish that up by attaching this. Now our system is complete. We'll tighten that with a wrench. And then we'll just pressurize this one to about 40, this one to about 50 psi, leave it for 40 minutes and see if it develops a leak. Okay, now that we finished our leak check and it passed, we're good to start the experiment for tomorrow. What that involves is we just have to heat up the decomposition chamber. We just seal it with cover it with a bit of KO wool to increase its insulation. And then we just plug in the heating elements. It's controlled by a PID. We have one that controls the temperature of the heating element, or measures the temperature of the heating elements. And then we have one up here that actually shows the internal temperature. So that'll be about 250 degrees tomorrow morning. And then we don't turn on the heating for this chamber until right before the experiment. So today we're running a carbonylation experiment. Yesterday our system was prepped, so they put reduced lunar regolith in this chamber and prepped the decomposition chamber. They also did a leak check, so we know that our system's safe. The first thing we're going to do the day of the experiment is we're going to vacuum out all the nitrogen they used yesterday, just so that we have a nice clean atmosphere when we put in the CO. Try and get as much pure CO as we can. So we'll get that going. We run the vacuum for about 20 minutes, and it usually gets down to about -3 inches of mercury, which is pretty good. And we hold it there for 20-ish minutes just to be good. So that's what the first thing we're going to do. Okay, now that the vacuum's run for about 20 minutes, we're just going to turn off the vacuum. I'll close the system off so that we don't have any gas getting pulled in and ruining our atmosphere. Then I will unplug the vacuum. Okay. We'll light the off-gas flame. This is just in case we have any CO that leaks through, or if we have a catastrophic failure on our burst disc, it gets burned rather than just escaping the atmosphere. Then we're going to load both chambers with a small amount of CO, just so that we know what our atmosphere is. We don't want to keep it under vacuum just because that's hard on the system. So we will make sure all of our lines are opened correctly, and then we will open the cylinder. And then we will slowly fill the system with CO. You can probably see it on this one better. Okay, now that that's loaded with CO, we'll isolate the decomposition chamber. This one's the decomposition chamber, this one's the reaction vessel. We'll isolate the decomposition chamber, and then we will load up the reaction vessel with its needed pressure. So our half-load pressure is 300 psi, so I will set the regulator to 300 psi. And then load up 300 psi. And it drops a little bit because the gas is cold. Everyone in the room will don ear protection for the final fill. And our calculated final fill is about 600 psi, so we'll fill it to that before we turn on the heater. And then after we heat it to 120 degrees, which is our experimental temperature, it should be about 800 psi, or about 54 atmospheres, 55 atmospheres. Okay. Okay. We will now fill. Our calculated pressure is in actual, so the gauge will be a bit below 600 just due to that fact, because I have to fill it up to about 14 psi below what I want it to be. Great. Okay, now that we're at our load pressure, we will turn on the cooling. This just prevents any thermal runaway from happening, because our reaction is exothermic. And then we'll turn on the heating for the formation chamber. So right now it's set to 150. We're doing only 120 today, so we'll bring it down to 120, and then we'll let it heat up. Okay, so if you can see here, we're actually a little bit over temp, but we're going to count this as our hot time. It took about 15 minutes for it to heat up, so we'll start our experiment. I will take a measurement now, and we will watch it every 15 minutes and take a value at that point.
So I guess we're going to do the sprint first. Oh, the sprinting of like, we're compound there and have it decompose over there. Do it real quick, and then check when the pressures are like the same on both there, and then we close it. Right? Okay. part's closed. We'll open that later. So first we gotta vent it out here. So and we're burning it here. Flushing out the system. By opening up all the valves, we're getting carbon monoxide left. So now we just have to close the regulator here and then switch it to nitrogen so that we can flush the whole system with nitrogen and make sure all the carbon monoxide goes burnt. I'll just stop the nitrogen first. Good.
Did you close the regulator?
Oh, I didn't. That makes sense why it's not completely low.
Yeah, you turn them to the right. Yep.
We don't have to record the rest now, right?
We should. I would turn the formation chamber off first.
I never did this.
So you'll just turn it off. There, then I would unplug these. Then I turn the gas off, or the water.